Welcome to Study Loop.
Let's evaluate the given integral. First, we should see if we can do a partial fraction decomposition. Now, looking at this denominator, this is really a quadratic in disguise. If you want, you could think of x to the fourth as x squared. Then we factor this as x squared plus 3, x squared plus 1. So we have two quadratics. And now we should check whether or not these quadratics factor. So let's look at the discriminant, b squared minus 4ac. So for the first polynomial, the first quadratic over here circled, we see that a is 1, b is 0, and we have 3 equals c. So for this one, we'll have 0 minus 4 times 1 times 3. That's a negative number. So as pointed out in the section, in the reading, this quadratic will not factor. Similarly, over here, we have b is 0, minus 4, and then a is 1, and c is 1. So we have negative 4 less than 0. So that means that this quadratic also doesn't factor. And now, using what the author would call case 3, non-repeated quadratic factors, and then for the second one, we have cx plus d, and then x squared plus 1. Now let's take both sides of this equation up here and multiply it by this expression, this denominator in the left side. After doing so, on the left, but on the right, we have ax plus b times x squared plus 1 plus cx plus d, and then x squared plus 3. Let's go ahead and expand out this right-hand side as much as we can. A cubed, bx squared, ax, b, and then for the second factor, we have cx cubed, dx squared, and then we have 3cx, and then 3d. Let's go ahead and factor out like terms. So here, let's take out an x cubed, factor that out, and then we're left over with a plus c. Then let's do the same for x squared, b plus d, pull out an x, a plus 3c, and then left over with b plus 3d. Now let's look at the coefficients on the left and on the right. On the left, we see that there's a 1 there in front of the x cubed. That means on the right, a plus c must be 1. We see that there's no x squared term on the left. That must mean that the x squared term on the right, the coefficient must be 0. So b plus d equals 0. The coefficient on the left in front of the x is a 2. On the right, it's a plus 3c. So those must be equal. And then on the left, we see that there's no constant term without an x value. So on the right, this constant term with no x must be 0. So let's write out and solve this 4x4 system of equations for a, b, c, and d. And when we do, we could replace the integrand with this expression up here in the red on the right, and then we'll integrate. So we have our system. A plus c is 1. We also had a plus 3c equals 2. B plus d equals 0. And then b plus 3d equals 0. So for example, if I just subtract the second equation from the first one, we have negative 2c is negative 1. So c is a half, and that implies a is a half too. Let's use the same method over here. Let's subtract b plus 3d equals 0. And then we have negative 2d equals 0. That means d equals 0, and then that also implies that b is 0. So now we have all four values, a, b, c, and d. Plugging those back into our partial fraction decomposition, we'll have 1/2 x, and then x squared plus 3, and then 1/2 x, x squared plus 1 on the bottom. So now let's go ahead and evaluate these two. We could pull out those constants. So let's go ahead and do that next. So 1/2, 0, 1. And we see here it looks like u sub will work nicely for both of these. Okay, so just pulled out the constants here. So now for this integral, the first integral, let's take u to just be x squared plus 3. Then that means du over 2 equals x dx, which is up here. So for this integral, we have 1/2. Watch out for those limits of integration. They may change. Here, you plug in x equals 0, and then we get u equals 3. That's our new lower bound. Plug in x equals 1, and then we get u equals 4. So that's our new upper bound. And then we have du over 2 on top. And then in the bottom, we just have a u. Now for the next integral, same idea, but this time u equals x squared plus 1. So du over 2 equals x dx, and we see that over here as well in the numerator. And we'll have to watch out for those limits of integration. So now plugging in x equals 0, we get u equals 0 squared plus 1. Plugging in x equals 1, we get u equals 2. And then up top, du over 2, and we have u again. Now let's evaluate each of these. We could combine these 1/2s. We get 1 over 4. Integral of 1 over u, natural log absolute value u. Then we have 3 to 4. So that's for the first integral. I should have kept this in red. So this is the first integral. And then now for the green, same integral, just different bounds. So we also have 1 over 4, combining those 1/2 factors. And then here we've already integrated natural log absolute value u from 3 to 4. So the last thing to do is to just plug in these endpoints and then simplify. Let's go to the next page for that. So plugging in the 4. So let's do the first integral on the left. We have ln 4 minus ln 3. And then for the next one, ln 2 minus ln 1. We know ln 1 is 0. So here we can just go ahead and maybe pull out a 1/4. And then we have ln 4 plus ln 2. That's ln of 4 times 2, which is 8. And then we're subtracting ln 3 so that we could put the 3 in the denominator inside the log. So really let me erase that parentheses. We have ln 8 over 3. And that's our final answer.